In this video, we will discuss the worksheet of topic quadratics and function as well. So here we have question number 1. As you can see that x minus 3, x plus 2 greater than 0. So we will move on critical values first. And the critical values are x is equal to 3 and x is equal to minus 2. That means if you multiply these two, it becomes x squared. So whenever you have y is equal to x squared, it is always u shape because the value of a is greater than 0. So we draw one u shape and one line. And remember, we have to say at the end it is either x is greater than 3 or less than 3. So for that we must know if it is increasing, so function will be this side or upside, and this side is decreasing. And inequality, it says itself says it's an increasing function. So here we have negative number, this is -2, and here we have 3, and x less than 3 gives us decreasing function and x greater than 3 gives us increasing. So it means x is greater than 3, and x less than -2 shows us increasing function, and x greater than -2, like let's suppose we have -1, it shows us decreasing. So as we are looking increasing, so x less than -2 will work. X less than -2, like -3, and we will find out the increasing function. I hope so it is clear. Next part, we will try to factorize first, and we can write it as an equation form first. X squared plus 7x plus 10 is equal to 0. Here our product is 10 and the sum value is 7x. So the product is 10 and the factor of 10 are 10 and 1, 5 and 2. So 5 and 2 will work for us. Like we can say that x squared plus 5x plus 2x plus 10 is equal to 0. So we have x common in the first part, which is x plus 5, and 2 common in the second part, so x plus 5. So we are getting x plus 5 and x plus 2. That means x is equal to -5 and x is equal to -2. Now again, this is a U shape because it has a coefficient 1, the coefficient of x squared, so which is greater than 0. That means it's a U shape. So if we have a U shape, and we can draw the line, and remember the inequality itself says it's a decreasing function. So if it is a decreasing function, here we have -5, -2. So we will focus on decreasing side, which is below the x-axis or below the line. So the value of x greater than -5 shows decreasing and less than -5 shows increasing. So we can say that greater than or equal to -5, and x less than or equal to -2 shows decreasing and greater than -2 shows increasing. So as the inequality shows us decreasing function, so x less than or equal to -2 will work for us. Again, we simplify first, like x squared plus 10x minus 12 plus x less than or equal to 0. So this gives me x squared plus 11x minus 12. I'm writing as an equation form so that we can find out the x values. So remember that here our product is -12 and some values is 11x. So which two number will help us to give 12, and if we add it must be 11. So 12 and 1 will work for us. So if I say x squared plus 12x minus 1x, it gives me 11, as well as the product these two is -12. So -12 equals 0. So here x is common, so x plus 12, and here -1 is common, so x plus 12. It means we are getting these two, x plus 12 and x minus 1. So x is equal to minus 12, x is equal to 1. If we check carefully from the decreasing function, as inequality says that it's a decreasing function and it is a U-shape because the coefficient of x squared is positive. So again, we can draw a U-shape and draw our line here. Here we have increasing function, down is decreasing, and we can write the negative value at this point, and this is positive value. So we can say that the value of x greater than minus 12 shows decreasing, and here it shows decreasing as well, greater than or equal to minus 12, and less than or equal to 1 shows us decreasing. So x less than or equal to 1. Next, question number 2. Express 2x squared minus 8x plus 5 in the form of a bracket open x plus b whole square plus c, where a, b, and c are integers. So remember, we are trying to use completing square concept here. So if we have 2x squared minus 8x plus 5, I can say that we will take 2 common. So x squared minus 4x plus 5, and I will try to complete or make perfect square here. So by taking the half value of 4, which is 2, so I will add the square of 2 as well as subtract the square of 2 plus 5. So this gives me x minus 2 whole square. 2 2s are 4, 4 multiplied by 2 8, so minus 8 plus 5, which gives me 2 bracket open x minus 2 whole square minus 3. And next, we made it the form, which is a bracket open x plus b whole square plus c is the form like this. And then we move on the second part of this question, write down the equation of line of symmetry. So remember that this is a U shape because the coefficient of x is positive, so it's a U shape. So we are looking the minimum value. And remember, the line of symmetry is basically a line which divides the object or shape exactly two parts. So it is always passed through the minimum or maximum point whenever we have U shape or N shape. So here we have y is equal to 2x square minus 8x plus 5. So we already found or made it the form, which is 2 bracket open x minus 2 whole square minus 3. So I'm trying to find the minimum point. We know it's a U shape. So this can be possible when this part x minus 2 is equal to 0. So it is possible only when x is equal to 2. So for x is equal to 2, this becomes 2 minus 2 whole square minus 3. That means y is equal to minus 3. So our minimum point is at x is equal to 2 and y is equal to minus 3. So this is our minimum point. And remember, if we try to draw, and this is your minimum point, which is 2 comma minus 3, and the line of symmetry is always passed through the minimum point. And remember that this is a vertical line, and vertical line represent x-axis, so x is equal to 2. So our line of symmetry is basically x is equal to 2. It divides the shape exactly two parts, and minimum point is 2 comma minus 3. I hope so it's clear. Now next, question number 3, find the discriminant for each equation and hence decide if the equation has two distinct roots, two equal roots, and no real roots. So remember the inner part of quadratic formula, which is b square minus 4ac. When it is greater than 0, that means we have two distinct roots. If it is b square minus 4ac less than 0, that means no real roots. And if it is b square minus 4ac equals 0, that means we have repeated or equal roots. So here a is 1, b equal 9, and c equal 2. That means b square minus 4ac becomes 9 squared minus 4 into a, c is 2. So that means 81 minus 8, which is equal 73. This is greater than 0. That means it has two distinct roots. Has two distinct roots or different root. You can say that. Next question or next part. B, here we have value of A is 3, B is 10, and C is minus 2. We will check discriminant again. B square minus 4AC gives us what? So 10 square minus 4A is 3 and C is minus 2. That means 100 minus minus plus 4 3s are 12 multiply 2 24, which is equal 124. It is greater than 0. Again, we have two real roots are two different real roots. It is the value of A is 2, B is minus 7, and C is 8. So we'll check in discriminant. It gives us what? So B is minus 7 whole square minus 4A is 2, C is 8. That means 49 minus 4 2s are 8, 8 8s are 64. So if we check 49 minus 64, it gives us minus 15, which is less than 0. So the discriminant or this equation or quadratic form has uh, no real roots. No. Next question is related to function, and we have given f of x is equal to ax plus 4, and for x belongs to R, and given that f of 5 is equal to 3, so I will utilize these relations to make an equation. Like f of 5 gives me 5a plus b. That means f of 5 is 3, so 5a plus b. This is equation 1, and we can check at f of 3 as well, and the same function. So it gives me 3a plus b, and f of 3 is basically equal minus 3, so minus 3 is equal to 3a plus b. This is equation 2. So once we solve these two equations, we can easily find the value of a and b by elimination method. So first equation is 3 is equal to 5a plus b, and second equation is minus 3a plus b. So we can change the symbol while subtraction. If minus, we will write plus. If plus, minus, minus. So cancel plus b minus b. So 3 plus 3 gives us 6. 5 plus 5 minus 3, 2. So it means a is equal to 6 divided by 2. That means a is equal to 3. So we found a, and then replace this value of a, one of the equation, like 3 is equal to 5 into 3 plus b. So 5 3s are 15 plus b. So b is equal to 3 minus 15, which is equal minus 12. So we find out both value of a and b. Those are 3 and minus 12. It means required function of f of x, which is in this form ax plus b. Now it is by applying or substituting the value of a, it is 3x minus 12. Now after this, we will try to find out the second part. And remember, this is composite function and function followed by another function, but it is multiplied by itself. Means f of x is what? 3x minus 12 is equal to 4. Again, apply or substitute this x minus 12 back in the same function, which is 3 bracket open 3x minus 12 minus 12 is equal to 4. So this is 9x minus 36 minus 12 is equal to 4. So 9x minus 48 is equal to 4. So this gives me 9x is equal to 48 plus 4, or we can say that 9x is equal to 52. And then lastly, x is equal to 52 over 9, or we can write in mixed number, which is equal 5 7 over 9. Next, question number 5. So it is find an expression of f inverse x for the following function, where function f of x is 5x minus 8 and x belongs to real number. So this is basically your domain. And as we are looking inverse function, so I will follow 3 points. The first point is we always write in place of f of x is equal to y. And the second point is we change the places of x and y. And the third step is to make y subject. Okay, so x plus 8 is equal to 5y, means y is equal to x plus 8 over 5. So this y represent f inverse x. So we find out the inverse function, which is x plus 8 over 5. In B part, also the same idea. First, y is equal to x square plus 3, and then we will shuffle or change the places of x and y. Like x is equal to y square plus 3, and then make y subject. So x minus 3 is equal to y square. So we can take square root as well. That means y is equal to square root of x minus 3, and this y represent f inverse x, which is equal square root of x minus 3. Next, question number 6, express the function in the form a bracket open x plus b whole square plus c, where a, b, and c are constant, and hence state the range of the function. So remember, if we have f of x is equal to y, then this x represent the input or domain, and the answer of y what comes, that is basically output, or we say range. So here domain is basically x belongs to a real number, and we are looking the range. This is the second thing. First, we will find out this form by applying completing square. So let's see how to find f of x. I will try to complete the square by taking the half value of x, which is 3. So 3 square we will add as well as subtract. And then this becomes x plus 3 whole squared plus, sorry, this is minus. So minus 9 minus 11. This gives me x plus 3 whole square minus 20. So as we know that it's a U shape because the coefficient of x square is positive. So we can find out the minimum point. Then it will be easy for us to say what is the range of this function. So for x is equal to negative 3, this part becomes 0. So f of negative 3 means negative 3 positive 3 whole square minus 20. In other words, we are getting minus 20. It means this is our minimum point, minus 3 minus 20, and it's a U shape. So the minimum value, basically the range we identify along y-axis. So the minimum value of y-axis is minus 20. We can say that the range of f of x is f of x greater than or equal to minus 20, means minus 20 and bigger value. Why? Because it's a minimum point, which is minus 20, and then above all values. Next, question number 7, and we have two functions, g of x and h of x. Both are belongs to real number, and we are looking composite. So g h of x is equal to x plus 5, and then replace back this 2x plus 5 in function g, which is x squared. So means 2x plus 5 whole square minus 2. So we can expand as well, like it is 4x squared plus 25 plus 2 5s are 10 multiplied 2 again. So 20x minus 2. This means 4x squared plus 20x plus 23. So this value or result we can use in B part as well, because gh of x equal 14. So gh of x we already found in first part. It is 4x squared plus 20x plus 23 is equal to 14. And of course, we have to solve to find what are the values of x. So 4x squared plus 20x plus 23 minus 14 is equal to 0. So 4x square plus 20x. So 23 minus 14 is equal 9. Now we will try to factorize. So if we factorize, our product is 36, means 36x squared and some value is 20x. So we are looking the factor of 36, means 18 and 2 will work. So that means 4x squared plus 18x plus 2x and plus 9 is equal to 0. So we have common 2x. So 2x plus 9. Here nothing is common. So 2x plus 9. It means we are getting 2x plus 9. And 2x plus 1 equals 0. That means x is equal to minus 9 over 2 and x is equal to minus 1 by 2. Next, question number 8, f of x equal x square plus 4x for x belongs to real number where x greater than or equal to minus 2. So remember it's a U shape, and when we have U shape it's a many one function, but in many one function the inverse function cannot be possible. It is possible only when we have certain value of x, like here they mention x greater than or equal to minus 2. For this value of x, this is one function, so we can find the inverse. F of x is equal x square plus 4x. I will try to make a complete square here as well, like x square, the half of 4 is 2, and we will add 2 square and subtract as well. So this gives me x plus 2 whole square minus 4, f of x. So now I will move on to find the f inverse is what. So first step is y is equal x plus 2 whole square minus 4, and then we will shuffle x and y, and then we will try to make y subject. So y plus 2 whole square is equal to x plus 4, and then by taking square root on both sides it becomes y plus 2 is equal to square root of x plus 4, and y is equal to minus 2 plus square root of x plus 4. And this is basically a inverse function of x, which is minus 2 x plus 4. So remember one thing, next part, B part, they are looking the domain and range of the function inverse, and basically the domain of function is the range of inverse function, and the range of a normal function is the domain of inverse function. Like the idea is, for example, we have f of x is equal to y. Here, domain is x, okay, and y is range. But if you say x is equal to f inverse y, then now x is range and y is domain. So I will apply the same idea here, but we know the domain, we are looking the range. So range is what? Basically, it's a U shape, so we must know the minimum value. So the minimum value of this function can be, like for example, you have f of x is equal x plus 2 whole square minus 4. The minimum value can be for x value of minus 2. Means when x is minus 2, although it is minus 2 here, so we have this part becomes 0, and it means we are getting minus 4. So the minimum value are minus 2, minus 4. So we need the y value, which will help us to say the range. So range of normal function is f of x greater than or equal to minus 4. So this is basically range of function f of x. Now, how to say the answer of this B part, the domain which is given here in the start, domain of f of x is the range of f inverse x. That means f inverse x is greater than or equal to minus 2, and range of f of x is the domain of f inverse x. That means x greater than or equal to minus 4. Next, question number 9. Find the f inverse x if it is exists. So whenever we have such type of question, we check through y is equal to x line, which is called the reflection line as well. So we will draw that reflection line. And remember, the points of reflection lines are x1, y1, like these points. -1, -1, -2, -2, -3, -3, here. So the line is exactly, this line represent a reflection line, or we can say that mirror line will help us to find the new inverse function. Like inverse of this function. So look from I will choose the endpoint. From endpoint to reflection line, or this line we have 1 2 3. So 1 2 3, this is the point. And here from function f to this reflection line we have two boxes down, so 1 2, and then just draw a line straight away. That line, this is basically inverse function of f. Here we are looking the equation of each of the graph after giving transformation. So basically this is translation, and in this translation is along y-axis. So we just add 4 in the given equation. The new equation will be y is equal to 2x squared plus 4. Second one is also the translation, and translation the vector is 0 minus 2, and it means 2 unit down along y-axis. So straight away we will add on the right side square root of x minus 2. This is the required new equation. And then this is also along y-axis. So this becomes y is equal to 7x squared minus 2x plus 1. And this is along y-axis also d. So x squared minus 1 plus 2 or x squared plus 1. And remember when we have translation along x-axis, then in generally y is equal f of x minus a. So this is translation of the of graph y is equal to f of x, and the translation vector is a 0, always opposite sign. So I will use the same idea here. So required equation will be 2 over x, here minus 5, okay? So I will say that plus 5 here. This is the required equation of translation after translation with the translation vector minus 5 0. So next one is again, this is translation along x-axis, because first point is given, so that means y is equal x minus 3, because it is plus here, okay, over x minus 3 plus 1, which is equal y is equal to x minus 3 over x minus 2. And next one is also y. We can say that this is minus, okay, so we would say that x plus 1 whole square plus x plus 1. You can simplify more further, but it's enough. I hope so it is clear. Last one, the translation is along x-axis and y-axis both. So when you solve this question, 3x minus 2 whole square and minus 2 plus 3. Or we can say that 3 bracket open x minus 2 whole square plus 1. I hope so it is clear. Next question number 11. Find the equation of each of the graph after the given transformation. So if we check carefully, this is basically reflection. So one thing you must know, when we have a function y is equal to minus f of x. So this is basically a reflection of graph y is equal to f of x in the x-axis. So remember, and if we have y is equal to f of minus x, so this is our reflection, y is equal to f of x in the y-axis. So here they already mentioned the first part, y is equal to f of x square after reflection in the x-axis. So if it is in the x-axis, we straight away multiply minus the right side of the equation. So y is equal to minus 5x squared. This is the required new equation after the reflection. B part, the reflection in the y-axis. So if it is in the y-axis, we will apply minus inside the x, means the new equation will be 2 bracket open minus x whole power 4, which is equal y is equal to 2x power 4. So this minus will become plus because the power is even form. Next C part, it is in the y-axis. So again, same idea. Y is equal to 2 bracket open minus x whole square minus 3 into minus x plus 1, which is equal to x square plus 3x plus 1. And here, this is in the x-axis reflection. So we just straight away multiply minus right side of the equation or curve. So which is 2x minus 3x squared. And this becomes minus 5 minus 2x plus 3x squared. Or you can write in ascending or descending order like 3x squared minus 2x minus 5. Yes, boys, this is question number 12. Describe the single transformation that maps the graph. So before solving this, you must know when the function y is equal to a f of x. So this is basically is a stretch of graph y is equal to f of x. It's stretch factor a parallel to y-axis. And if we have the function y is equal to f of ax is a stretch of graph y is equal to f of x, then the stretch factor is 1 over a and parallel to x-axis. So remember this concept that will help you. So here the first case y is equal to x squared plus 2x minus 5. If you check the answer is given which is 4x squared. They are trying to substitute in x. So that is surely along x-axis. So we can say that it's parallel to x-axis and with stretch factor 1 by 2 because they substitute 2 here so that it becomes 4. It means stretch factor must be 1 by 2. Means if you apply, you can check here 2x whole square plus 2 into 2x minus 5. That gives you exactly 4x squared plus 4x minus 5. So same equation. I hope so it is clear. Next one, if you check the B part, they are trying to multiply the right side, even they multiply with 2. So that means it is parallel to y-axis with stretch factor. Look, 2 multiplied by 3, 6. So they are multiplying 3 right side, like 3 bracket open x square minus 3x plus 2. This becomes 3x squared minus 9x plus 6, exactly the same thing. So it means your answer is parallel to y-axis, only you have to describe with stretch factor 3. And lastly, if you check carefully again, they are multiplying right side by 2. So it means it is parallel to y-axis, with a stretch factor. And if you want to check, so 2 multiplied by 2 multiplied by x plus 2 into 1, which is equal to power x plus 1 plus 2. So exactly same thing. So this is your required description, parallel to y-axis with stretch factor 2. They are not changing minus 6 as well. So something change in x. So it is parallel to x-axis, with scale or stretch factor 1 by 3. Because 1 by 3, you will write here 3x. You can check also square root of 3x minus 6. So exactly same thing. So this is our description. Parallel to x-axis with stretch factor 1 by 3. Next, question number 13, the following function and find an expression f inverse x and hence decide if the graph of y is equal to f of x is symmetrical about the line y is equal to x. Remember when we have self-inverse function, self-inverse function is only when f and answer of f and f inverse both same, then it is called self-inverse function. And in this case there is a symmetrical about the line y is equal to x as well. So here if we check, this one would be y is equal to x plus 5. I'm looking the inverse of this, 2x minus 1. So we can cross multiply, but before cross multiplying you can change x and y. So x is equal to y plus 5 over 2y minus 1. And then 2xy minus x is equal to y plus 5. Just bring a y value together, like 2xy minus y is equal to x plus 5. We can take y as common, so 2x minus 1, x plus 5, and then y is equal to x plus 5 over 2x minus 1. That means this y represent inverse function. So x plus 5 over 2x minus 1. This is exactly same as the answer of given function f of x. So it means this is self-inverse and it is symmetrical about the line y is equal to x. We'll check the second one also. So if we check this one, y is equal to 2x minus 3 over x minus 5. Now we'll change the x and y. So this is 2y minus 3 over y minus 5. And then we can cross multiply as well. So xy minus 5x is equal to 2y minus 3. So try to bring y together. So xy minus 2y is equal to 5x minus 3. So we can take y common as we are looking y as subject. 5x minus 3. So y is equal to 5x minus 3 over x minus 2. Or this is f inverse x, which is equal 5x minus 3 over x minus 2. But this answer is different if we compare with f of x. So this is not self-inverse, not self-inverse function. We have f of x, x square plus 6 for x belongs to R, and g of x is square root of x plus 3 minus 2 for x belongs to R and x greater than or equal to minus 3. We are looking f g of 6. So we straight away apply or substitute 6 in g, like 6 plus 3 minus 2. So this gives me 9 minus 2, which is equal 3 minus 2, which is equal f of 1. And now we can replace 1 in the function f, which is 1 square plus 6. So 1 plus 6 equals 7. Now we can check gf of 4. So for that, we can straight away apply 4 in function f for 4 whole square plus 6, which gives me 16 plus 6, so which is equal to 22. Now we can apply 22 in the function g. So 22 plus 3 minus 2, which is equal 25 minus 2, 5 minus 2, which is equal 3. So we found the value. This question is state the domain and range of the given function represented by these two graphs. So remember, when you are looking domain, we always check the minimum and maximum value of x, or we check along x-axis. So here the minimum value of x is minus 3, minus 1, and maximum value of x is 5. So our domain is minus 1 less than or equal to x less than 5, and range always along y-axis, so minimum value of y and maximum value of y. So minus 8 less than or equal to y less than or equal to 8. Part of this one is again domain and range. So domain, the minimum value of x is minus 3 and the maximum value of x is 2. So here minus 3 less than or equal to x less than or equal to 2, and the minimum value of x y is minus 7 and maximum value of y is 20. So minus 7 less than or equal to y less than or equal to 20. I hope so it is clear. Thank you for watching.